Hello friends, welcome to Engineering Funda family. In this video, I am going to explain you interrupt driven IO. In my previous video, I have explained you programmed IO, and in that we have seen there was too much time which was there in terms of idle state with CPU. Like if you see in my previous video, I have explained CPU is way faster compared to IO devices. Here I have considered example of CPU with operating clock cycle frequency of 1 gigahertz and IO was operating at 1 kbps. So when CPU was executing instruction, at that time it was asking for a data to be loaded inside accumulator as per LDA, right? And here IO device that was slow, it was functioning at 1 kbps. Because of that, it will be generating that data with the speed of 1 millisecond, right? And for that 1 millisecond, CPU will have to wait. As CPU is having clock frequency of 1 gigahertz, it is just need to have 1 nanosecond time period of 1 clock cycle to have that data. But because of this IO device was slow, it will have to wait till this IO device respond to the CPU related this instruction, right? So that was the issue. Now how to resolve that issue with the usage of interrupt driven IO? Let us try to understand that. So here again same example that I'm going to consider, like CPU that is working at 1 gigahertz of frequency. So with one clock it will be taking 1 nanosecond time period, right? Now here let us say I'm having IO device that is functioning at 1 kbps speed, right? Now here we are executing one program in which again same instruction that is encountered to the CPU, that is LDA. LDA means load direct accumulator with the port address IO0. So port address IO0 that should give data to accumulator, which is a register inside CPU, right? So when CPU is generating this address as per LDA, that address will go on system bus. Now this address that will be given to programmable interrupt controller. Previously we were not been using this IC, right? You see here that system bus that was directly connected with CPU and IO devices, right? But now rather we interface this system bus with IO device, we are connecting that with 8259 programmable interrupt controller IC. See, this is the IC which we were been interfacing it with initial microprocessors like 8085, 8086. Nowadays, IO interface ICs are available. But just to explain you how exactly things are happening, you can consider this example. All those IO interface ICs that is functioning similar to this. Only thing is there are some advancements because of which that is bit faster compared to this IC, right? So now what is happening is CPU is executing this instruction and it is asking for the data to be loaded from port IO0 and it should be loaded inside accumulator, right? So now see what will happen. Now that request that will be taken by 8259 IC. Now once 8259 IC that is taking this port address, right, then now CPU is free to do other work. So now what will happen is practically CPU will pause execution of this program over here and it will perform some other program, right? It will not wait over here, it will execute some other program. While it is executing this other program, what this 8259 IC will do is 8259 IC that will tells this IO port to give data, right? So first it will send request to this IO port. Once IO port receives that request, it will give that data to 8259 IC. And you will be observing with 8259 IC, there will be buffer over here. Now, what will happen is this IO port that will take 1 millisecond time only, right? As it is slow. And it will give that data and it will fill that data inside this buffer. Once that data is completely full over here inside buffer, 8259 IC that will give interrupt to CPU. So now CPU will get to know like, okay, interrupt is given by this 8259 IC and based on that it will give interrupt acknowledgement to this 8259 IC. Once that acknowledgement come over here, 8259 IC that will place data over this system bus. After that CPU will read it. So let me explain you all those things step by step. What will happen is, first CPU will ask for the data from this port address. So CPU will give request over here. So that is step number 1. Now that request will be received by 8259 IC. So 8259 IC that will give same request to the mentioned port as per CPU. So second thing that will happen is, this 8259 that will give request to IO port. Now based on this request, this IO port that will give data to 8259 IC, and that is getting filled inside this buffer. So that is step number 3. Once that buffer is completely full, 8259 IC that will give interrupt request over here to CPU. So this is step number 4 performed by 8259 IC. Once that interrupt is received by this CPU, it will give interrupt acknowledgement to this programmable interrupt controller. So that is step number 5. Now once this interrupt acknowledgement is received by 8259, 8259 will place this data of buffer on this system bus, right? So 8259 that will place this data of buffer on system bus, that is step number 6. Now once that data is available on system bus, CPU will read it, right? And it will load it inside accumulator. So that is what step number 7. So you will be observing there are total 7 steps that is happening, right? And as this buffer is very fast, and this 8259 IC that is way faster compared to this IO port, you will be observing execution time that will decrease. Like in general, you will be observing 8259 IC that is executing all this stuff within the time period of 0.5 microsecond, right? So for this much amount of time period, you will be observing this entire thing is happening. Previously, if you observe, with the slower device like keyboard, it was waiting for 1 millisecond, right? Now you will be observing, because of that waiting time period that is given to this 8259 IC, now CPU is free to execute another program while all these things are happening inside 8259. So now that waiting time period that is significantly decreased to 0.5 microsecond, right? So here you will be observing, because of 8259 is handling all the interrupt request, now job of CPU is to execute another program in parallel with that given program. So here you can say CPU block time period that we are decreasing over here, right? So you can say from 1 millisecond to 0.5 microsecond, we have decreased that blockage time period of CPU, right? So this is how interrupt driven IO is functioning. Like there will be IO interface IC. In advanced processor, you will be observing, instead of this 8259 programmable interrupt controller PIC IC, you will be observing IO interface ICs will be there, right? Job of those IC will be same as this. Only thing is those ICs will be a bit advanced one, in which you will be observing that time period is not 0.5 microsecond. It will be there in terms of tens of nanoseconds, right? So that is bit faster compared to this one, but that way of functioning that will be similar, right? So you can say here we are reducing that CPU blockage time period as it was happening with programmed IO. But still with this system there is one issue. Let me address this issue over here. Like for example, here we are having IO device which is disk. Now this disk wants to transfer data to this main memory. Then what will happen? Even this disk wants to transfer this data to main memory. All these steps that will be getting executed as per the sequence which I have mentioned over here. Let me give you one example. For example, as if you want to transfer 1 MB data. 1 MB means 1 megabyte. Let us say here this system bus that is having one word is equals to 1 byte. So in that case, what will happen? This process that you will be repeating how many times? 1 million times. And as you repeat this process 1 million times, you will be observing 1 million into 0.5 microsecond that you will have to have with CPU, and at that time CPU cannot do anything, right? So as if you want to transfer this data of this to main memory, at that time as if we bypass this CPU's operation, then it will be very good. Like, see, for example, as if I say this data of disk of 1 MB that we are transferring over here to main memory without bothering CPU, and we allow CPU to execute any other program, in that case that will be excellent thing, right? But that is not happening over here with interrupt driven IO. And to have this, to bypass CPU while you transfer data from disk to main memory, you will have to understand how direct memory access functions, right? So in next video, I'll explain you how DMA, direct memory access functions, and based on that, you will get to know like how exactly CPU is functioning with IO device as per direct memory access, as well as how we can optimize that blockage time period which is there with CPU to optimize the performance of CPU. I hope it is clear to you. Still, if anything that you like to share it with me, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.